thought-provoking keynote address. Your words, not only it was about the multidisciplinary aspects of built environment, however, it touched upon the multidisciplinary aspects of life, actually. So your words have undoubtedly set a high standard for the discussion that will follow throughout this conference. Now I would like to request Architect Kanika Verma, Associate Professor, APG Institute of Technology, to take over forward from here the section.
Thank you so much, ma'am. Now to taking it forward, I would like to welcome Dr. Professor Moinuddin, who have this distinguished professor and chair technical research, APJ Satya University, Gurugram, India, who is with us as a guest of honor. Dr. Moinuddin is a distinguished professor and chair of technical research with 45 years of teaching and research experience. He has held prestigious positions, including Director of the National Institute of Technology, Jalandhar, Pro-Provost Chancellor at Delhi Technological University. He has also served as a professor and dean at Jamia Millia Islamia and Jamia Hamdard University in New Delhi. Internationally, Dr. Moinuddin has been a faculty member at University of Saladin in Iraq and has visited numerous universities in USA under the network scheme sponsored by MHRD. These institutions include MIT Boston, Michigan State University, East Lansing, Pennsylvania State University, University of Pittsburgh, and Carnegie Mellon University, Pittsburgh. During this time in the USA, he submitted a detailed project report on the technical education of US universities. Dr. Moinuddin has been a member of various executive councils, academic councils, and board of studies at several universities and institutions. He has served as a visitor nominee to NITs and state universities and has been a member of numerous regulatory bodies, including DART, Indo-Japan Fellowship Award Committee, AICTE, MHRD, UPSC, and UGC. His research endeavors have been supported by substantial funding from AICTE, DST, UGC, and the World Bank under TEQIP grants, totaling rupees 30 crore. He has also designed 3 computer science for Tribhuvan University under World Bank sponsored project. And his extensive contribution to academia and research have significantly advanced technical education and research in India and abroad. We are thankful to Sir to be a part of this conference. I would now request and call upon Sir to share his experience with us. Sir, up.
So you'll have to unmute yourself.
Sir, kindly unmute yourself. Yes, thank you.
Very good morning to all of you.
Good morning, sir.
Yeah. Just give me a few minutes to share my screen.
Host disable the participant sharing.
Please allow to share my screen.
Yeah,
Sir,
Kapil
please
sir.
share. Please share.
Kapil sir.
Try again. You are allowed to share your screen.
Yeah.
The first one.
Yeah, very good morning to all of you. First of all, I convey my sincere thanks and appreciation to Vivekji for organizing such a great conference and giving me an opportunity to share my experience related with the new technology which are coming up and facing challenges to architectures. My topic is challenges and opportunities of sustainable architecture.
presentation.
Today phase is phase of the technology which is recognized or given number of nomenclature assigned to present phase of technology. For example, the first word or first term which is used, that is called VUCA word. VUCA here stands volatile, uncertain, complex, ambiguous. This is the term, this is the word which is assigned to present present phase of the technology. The other phase is called in the fourth industrial revolution, or this is called I 4.0. And the name assigned is disruptive technology or digital transformation. Some people, they are saying ChatGPT also, or Copilot. And that term which is related with the technology development, this is called 5G. Now 5G, we also referred as towers of concern, because this technology is emitting a lot of electromagnetic radiation to environment and causing serious health concerns. And that term which is related with present phase, this is called robotization, flexible manufacturing system. Somewhere you'll find IoT or double IoT, Chandrayaan 3. With the same phase of development technology, somewhere people call blockchain, cloud computing, transformative AI, generative AI. And recently, you can call 4A, that is called automation, augmentation, assistance, and autonomous. All these terms lead to a new term, new engineering term, which is a result of fusion of or integration of several technologies we call dawn of new horizon. So today is a phase, what we call, or technological phase, what we call dawn of new horizon. The dynamics of the present phase of technology naturally creating a lot of physical dimensions, or the technological dimensions, but pushing a lot of pressure to architects, professionals who are involved in designing infrastructure necessary for nation building. Now this phase is called unpredictable, because changes or the forecast you cannot predict accurately, precisely, using conventional mathematical tools or engineering tools. The system is vague. The information that you are getting, whether you are getting climate information, you are getting the images from satellite, remote sensing, etc., all have certain amount of errors, ambiguities. Moreover, the data set that we are using, it will be helpful to design the complex structures, highly complex, multivariable, or somewhere you can call the data, and most of the data we call real-time data, multidimensional data. As a result, it's very difficult to model or forecast the future. So when we don't have the sufficient data, accurate data, so that we can precisely model, and this model may be given to scientists, engineers to design new buildings, new infrastructure, which is necessary for sustainable development. And the data is time variant also. From where I mentioned here, real-time data, time variant data. The product have a shorter half-life cycle. Now, result of integration of technologies, this called smart phase of technology, smart and intelligent solutions required by scientists, engineers, architects for sustainable development. The objective functions of today's technology innovations are increase efficiency, precision and accuracy, consistency, faster processing, low-cost solutions, reliability, multi-objective optimization, visualization. Thus, scientists, engineers, architects, professionals, management professionals, they need spatial analytical technological tools like artificial intelligence, machine learning, big data, advanced mathematical techniques, powerful computing and communication network, virtual reality, advanced AVR, smart sensor, drones, cloud computing. Thus, architectural science for this subject is interdisciplinary and multidisciplinary as of today. Somewhere you can label it, the present phase belongs integration, multiplication, multi-operation condition, leading to boundaryless research space for scientists, engineers, architects, professionals. This phase is also called, with respect to India, you can call smart city phase, smart building, sustainable development, where you need a lot of images from satellite, and you can forecast the weather condition to determine the thermal issues, the environmental effect of the building. We are using for testing of the building what we call non-invasive technique, computerized techniques, computerized technology, control, monitor, assessment, analysis, value extraction, everything. So this phase of technology needs to be adopted, to be followed by all branches of science and engineering, including architect. Big data analytics is one of the engineering subject which is emerging at a fast rate, and it requires that scientists, engineers, technocrats, they have to adopt, they have to learn the art or dynamics of big data analytics, because you can comprise what you call the big data Wi-Fi Vs. So analytics is a term that includes the processes, technologies, framework, and algorithm to access desired information, wanted information from the past and present data sets, and forecast future to determine the patterns and cost-effective solution of the system. Our classification of data analytics or big data analytics is descriptive analysis, diagnostic analysis, predictive analytics, prescriptive analysis, cognitive analytics. All these analytics are to be studied or need information to be known from the data set that we get from various sources, whether from environment, whether we get information from the various critical infrastructure which are needed for nation development. Now the question is that we are debating, what are sustainable goals? And sustainable goal is a serious issue before every one of us. So according to United Nations Development Protocol that has designed 70 Sustainable Development Goals by 193 member states in 2015, also termed as Millennium Goals, and assigned the term Save Planet. So architects have a role to play to manage, to control some of the critical infrastructure system in order to save the planet. All member states will agree to achieve the task. By 2030, the progress is quite slow. Each goal has targets and indicators. Now, the field of architecture engineering or architect is facing complex challenges on a term which is used, what you call safe planet. This is one of the main target mentioned in 17 sustainable development goals. Now, out of these 17 sustainable goals, there are some goals which are especially related with respect to architectural engineering, architects, or science engineers who are involved in designing and constructing the building, the infrastructure. I have identified what are the 4 goals, which are, of course, needed, what you call, say, planet. So, say, goal number 6, goal number 7, goal number 11, and goal number 13. The first is clean water and sanitation. The nation, every country is struggling to provide clean water. Shortage water, even if you take, for example, Delhi, it's difficult to get the clean water. Sanitation is a problem. Waste management is a serious issue that we are facing as of today, especially in metro cities. We need green energy. As in India, with respect to EPI, we are at the almost 177 index level out of 180 levels. So our energy consumption, energy generation, we are at the bottom in terms of producing great energy, or what you call the energy. We are trying to work out the green energy, or what we call the alternative energy sources. At least the target is that by 2030, India will be able to will have at least 30 to 40% energy share associated with green energy component. The goal number 11, sustainable cities and communities. Yes, India is working on this project, sustainable city, what you call smart cities, smart building. Goal number 13, climate action. This is one of the most critical aspects of today, the discussion. The carbon footing, the carbon, what you call zero net emission, that is the target to achieve, is very, very difficult. Now, to address these issues, architects, technology, experts are responsible to play a critical role in achieving almost all 17 sustainable goals, but out of the 17 goals, goal number 6, 7, 11, and 13, that is the priority item related with what we call, say, planet. Now, the first definition that is related with sustainable architect. Sustainable architecture is a broad term being used for designing and construction of critical infrastructure for nation building, including, of course, buildings, commercial buildings, residential buildings, other class of building, transport system, healthcare, safety and security, disaster management issues, water, air, land, defense, agriculture, waterways, power plants, etc. So sustainable architecture is a broad term, or sustainable architectural engineering is a very, very broad term being used to address multiple parameters, multi-variable task and the indicators which are needed for nation development. We study and research the impact analysis on environment and climate change. Infrastructure goals 6, 7, 11, and 13 are at the forefront. They are needed to increase the resilience, more robust, energy efficient, reliable implementation support system. So the future architect or architecture engineering requires a lot of analysis, lot of research to design a special class of critical infrastructure which are needed for national development to satisfy not only goal number 6, 7, 11, and 13, but also all 17 goals as prescribed by the Sustainable Development Goal Protocol designed by United Nations in the year 2015. The next topic that I'm going, challenges for sustainable agriculture, engineering, environmental, technological, research, culture, and socio-economic. Under these four groups, we have following almost 16 or 18 challenges that we are facing as of today. This branch of engineering, the first part is environmental sustainability. Design buildings, design critical infrastructure for nation building, which includes all class infrastructure, not only building, transport system you require energy, you require healthcare system, you require education. So sustainable environmental issues are more crucial, more desirable to make any design or construction of critical infrastructure which are needed for nation development. It should be eco-friendly, what we call eco-friendly construction. The second issue is urban densification. Naturally, there's a lot of migration from rural to urban area, what we call regional divide. The available space in metro cities is limited, and the possible solution would be vertical spaces, high-rise building. So architects have a responsibility to optimize the space. For optimization of space, you require machine learning techniques, deep machine learning, fuzzy logic deep optimization techniques, emerging technology, integration. Naturally, no science or no subject or no engineering is standalone. It involves other branches of engineering as a branch of science also. So you require the integration, fusion, merging of technology for future-proofing buildings, for future-proofing infrastructures, whether these are buildings, roads, railways, airports, or any other physical infrastructure which are core part of any modern society, advanced nation. Yes, next part is, these are my listed challenges that we are facing as of today. Collaboration of diverse stakeholders. So you need collaboration, you need teamwork, you need multiple agencies, multiple group of the people. You identify the solution, you identify the problem, and you can find a smart solution. Smart material. Smart material is one of the critical components that's needed. Nowadays, you require that material must be energy efficient. You require that the building material, the building that we are constructing should consume minimum energy. Disaster management, authorization building, this is the other part that you have to take into consideration because these are natural disasters which may occur any time. Now, disaster management could be the earthquake, it may be because of the flood, it may be because of the tornado and other natural the effect. Smart design consideration. This is the area that we have already specified. This is smart technology phase. So you require smart solutions. Use new design techniques. Do some research to design new verticals, new road systems for managing the energy efficiency, managing the environment, managing the optimization of the materials. Yeah, design what we call next universal design for inclusiveness. Think that how can you provide access to low-income people? They should have a center, the space where they can live comfortably, cost-effective solution, renewable energy sources and smart green energy. This is another consideration, and when we talk about the smart building, when we talk of the smart cities, when we talk green building, naturally, the first and the most important term that comes into mind, how can you make the building energy efficient? How can you make that the construction and the operation of the building does not produce large amount of carbon dioxide? It should be so that it can impact or affect on your environment. Water, air, water, land. These are the three basic natural resources. Water is very important, crucial for the survival of human being, like air. So linking of river is one of the projects initiated by former President Dr. Apj Abdul Kalam, linking of the river so you can manage the wastage of water effectively. Harvesting of rainwater, design new technology to harvest rainwater, not only at a large scale, but smaller buildings also. Every institution should have a provision to harvest water, save water, minimizing the carbon footprints. Every process generates certain amount, every construction, every process, every manufacturing system, by and large, generate large amount of undesirable gases. To minimize the gas emission, net zero emission, that should be the effect. Of course, every country is working to provide sustainable development for air, socio-economic consideration and access, affordability. Yes, India is a country where you have 1.5 billion people, they are living. You have large section of people who are below poverty line. Once you are designing a building or creating infrastructure, you have to give weightage or socio-economic consideration. Smart cities, smart building, green building. These are the technologies which are already in operation. People are working, scientists are working, architects are working to give better and better solution. Clean water and air quality. Cultural preservation. once you are designing a metro city or new building, give weightage to culture, to save culture, to save heritage building. I think Dr. Hasib Khan, he has also pointed out, was talking about the construction of new building. You have to give weightage of the culture and heritage building preservations. Fortified construction for resilience against disasters. Naturally, this phase of technology where you are using, especially in urban cities, the multi-story, multi-high-rise building, and design must be such that it should be able to sustain the effect of various disaster effects like earthquake, flood, and then also what we call Toronto or some other types of wind effect. They generate a lot of high wind. The building must be able to sustain high wind pressures. Managing digital divide. Now, managing a rural and urban divide. Provide critical infrastructure. It should be accessible, it should be affordable to large section of rural population. Large section of population which are below the poverty line. So you have a role to play. So these are some of the challenges which I have shortlisted that future architect, future technology, future engineering must be able to address these very complex and critical issues while taking up the design and construction of the physical infrastructure for nation building. Architects' intervention and responsibilities. Reduce environmental impact, design building, green building. Reduce carbon footprints. Employ, use as much as renewable energy as possible. Design small, micro and mini hydroelectric power plants. Solar plants. As India, I think by 2030, we are expecting 30% will be the power will be generated from renewable energy sources. Wind, biomass, smart grids, etc. Water harvesting, integration of rivers, optimization of water use for irrigation, avoid losses in water supply system, launch awareness programs so that people are to be trained to save water, as much water as required, use smart and energy efficient materials for construction of buildings and cities infrastructures, use new technology that is called drone technology for smart agriculture system. Use drip water technology for irrigation, for integrated farming. Encourage vertical spaces, high-rise complexes, multi-user structures. Integrate residential, commercial, medical, community services, urban densification, better connectivity, road balancing, ensure structural resilience, crowd management, flexible structures, multi-user spaces. Of course, technology or architecture engineering. Hello? I think I'll do that. Cutting technology, more automation feature, light, temperature control, automation systems, security data, smart materials, cost-effective solutions, fortifies construction for resilience against a natural disaster, future frontiers, emerging challenges on the horizon, with the emergence of new digital technologies, architects must learn and upgrade their knowledge of new emerging technologies for design, construction, and services. Use AI, ML, big data, business. Thank you very much for 1 or 2, 5 minutes, maybe for question and answers. I think I have completed my task within this stipulated time.
Yes, sir, you have, sir. No, we're very thankful for your speak, sir. Hello.
Yes, please carry on.
Thank you. Thank you so much, sir. It was a very captivating and thought-provoking keynote address. We're thankful to have you. Your words have undoubtedly set a high standard for the discussions that will follow throughout the conference. Now, with this, I would like to conclude the inaugural session of our conference. I once again thank all our esteemed guests and speakers for their invaluable contributions. Let's move forward with the spirit of curiosity and collaboration. Before we take a short break, I would like to humbly acknowledge the absence of our conference's convener, Dr. Dipashri Chaudhary, due to an unfortunate personal loss she faced this morning. Dr. Dipashri Chaudhary is an architect and urban designer with over 22 years of experience in architectural practice and academics. She's at present a professor at School of Architecture and Planning, APJ Institute of Technology, Greater Noida, India. Her contribution to this conference has been immense, and we deeply